Hello, this is Mr. Huber. In this lesson, we're going to look at two variable inequalities, absolute value versions of those. We saw some inequalities in two variables that were linear inequalities, where we graphed the line and shaded one side or the other. With absolute value, we're going to do something very similar. We're going to graph an absolute value function. Let's say it might look like this. And then we're going to figure out where to shade. So we're either going to shade kind of inside of the V or around the outside of it. And we'll do that by testing a point, just like we did when it was a line. So we're going to graph the absolute value, and then we're going to figure out where to shade, similar to what we did with linear inequalities in two variables. So let's see an example. Okay. If we want to graph this absolute value inequality, the first thing we need to do is graph the inequality, like there was an equal sign there. So we're going to do this as if this was an equal sign. Okay? And we can get a vertex from the equation. The vertex, right, is going to be at -3, 4. We get that from our x minus h, y plus k. Okay? So we get our x and y values from our vertex like we did any other time we had an absolute value. And if we plot that point at -3, 4, then we can draw our graph from there with a slope of 1, right? This number in front of the absolute value, there's nothing there, so there's a 1. That means the branch of the absolute value goes up 1 over 1, up 1 over 1, and we could draw that side of the V, and then same thing on the other side. So that's our absolute value graph. Now the inequality part, so let's get rid of that equal sign and say now if we had an inequality, we want to test a point. So let's pick the point 0, 0. And those are usually pretty easy numbers to plug in. So we're going to have y is greater than 0 plus 3 and plus 4. Remember, the 0 plus 3 is an absolute value. So we should put a 0 in for y over here as well. We have a y value of 0 and an x value of 0. So we're going to have 0 is greater than the absolute value of 3 plus 4. The absolute value of 3 is still 3 plus 4. So we're going to have 0 is greater than 7. That is not true. So we do not want to include this point in our shading. 0, 0 right here was not a solution, so it should not be part of what we shade. Instead, we're going to shade, instead of this part of the graph, we're going to go and shade this part kind of inside the absolute value. So we can do that like this. And we shade in there, and that would be our graph for that absolute value inequality. If you picked any point that's inside here, like if you picked the point -2, 8, and plugged it in for x and y, it will make this inequality true. Right? The shading is telling us that that's all part of the solution. The one other thing we have to fix, we look at here, we had a solid line. Since it doesn't have the equals to, we should have a dashed line. We can go back right now, and we can just make that a dashed line, right, on both sides. So we do a little dashed line. And if you don't recognize that at the beginning, right, you can go back and make it a dashed line. So a dashed line because it doesn't have the equal to. Right? So keep that in mind like we did with equations of lines, inequalities of lines. We graph with a solid line if it's got the equal to, and a dashed line if it doesn't. Okay? Let's check out another example. So here we have y is less than or equal to -2, absolute value x minus 5. So the vertex is going to be at 5, 0, right? X minus h, and then plus k. This is our h and our k. So the h is 5, the k is, there's a plus 0. It's not written there, so it's a 0. So we'd go to 5, 0, and that would be our vertex. And then we can graph the branch of this. -2, negative, remember, means it's going to be flipped upside down. Okay, so we're going to graph it upside down, and we're going to have a slope of -2. So when we go to graph that, we're going to want to go down 2 and over 1. Down 2 and over 1 on both sides. And we could draw then in that absolute value. We've got both branches of that V going to either side of our vertex. Okay? And now we could pick a point to test. Again, I would suggest 0, 0 because that makes most of the calculations pretty easy. So we have 0 for y, less than or equal to -2, absolute value, 0 minus 5. 0 is less than or equal to -2, and then the absolute value of -5. So 0 is less than or equal to -2 times a positive 5, right? Absolute value of -5 is 5. That 0 is less than or equal to -10. Okay, 0 is not less than or equal to -10. So again, we do not want to shade the part of the graph that has the 0, 0 in it because this point was not a solution. So we don't want to shade this part. We're going to shade in here, and so we can do that and shade here, and it should be solid lines on our graph. We can double check that because we have the equals to. So because of the equal to here, that means we have solid lines on our absolute value graph for that V. Okay, remember the negative was because it was flipped upside down. So that's what our graph looks like in our shading. And again, let's pick a point that's inside there and actually check it now. So I'm going to say let's pick the point right here. Okay, so I just put a kind of a green dot there at 6, -4. So let's check out the point 6, -4. Okay, so we'll erase what we have here, and we're going to check 6, -4. And again, any point in that blue shaded portion should work. Okay, so if we do 6, -4, that means a -4 for y, less than or equal to -2, absolute value of 6 minus 5. So change that up there. We don't want to parenthesis. We'll put the absolute value bar there. So we have -4 less than or equal to -2. 6 minus 5 is 1, so the absolute value of 1 is +1. We have -4 is less than or equal to -2. That's a true statement, right? That's why that is part of our solution. That's why this is part of what's shading. And any point in here, or even a point on the line, will work and make that inequality that we started with true. All right. Before we do one more example, and you're going to pay attention for that third one because it's got a couple interesting pieces to it. Royal Relief here. What is the only U.S. national park in Michigan? The only U.S. national park in Michigan. There's national parks all around our great country. The only one that's part of Michigan is this island right here. This island and a bunch of little surrounding islands. It's called Isle Royale National Park. Isle Royale National Park. And this big island here is Isle Royale. And believe it or not, there's 250 other little islands around there that are all part of the national park. But that big island, Isle Royale, is the major part of it. You can see a picture over here on the side of some of it's really just pristine wilderness. Okay? And it is the third largest island in the contiguous United States. Okay, Isle Royale is the third largest island in the contiguous United States. It's 45 miles by 9 miles. It's actually, as you can see, a lot closer to Canada and Minnesota, only about 15 miles away from the borders of Minnesota and Canada. And there are no permanent residents on the island. No one lives on Isle Royale. There are people there seasonally, and people can take ferries there and travel to there. And there's a lot of great backpacking and outdoor wilderness that goes on, but nobody actually lives in Isle Royale National Park. Okay, so a little interesting fact about our great state of Michigan. Let's do this third example that's going to bring up a few interesting things to pay attention to. The first one is that the y is not all by itself. Y is not all by itself already, so we need to get that y by itself. So if we bring this equation over here so we can do a little work with it, we're going to have 1 minus y less than absolute value of x minus 5. So first thing we'd want to do is subtract 1 on both sides. We're going to get that y by itself. So we have negative y, don't forget that negative sign, less than absolute value of x minus 5, and then minus 1. Okay, right? We can't subtract the negative 1 from the 5 that's in the absolute value. And now we're going to divide everything by negative 1. Divide everything by negative 1. So that cancels the negative. We have y, and then don't forget to switch the direction of the inequality. That's a key piece to this. We have to switch the direction of this inequality. When we divide by a negative, that less than becomes a greater than. And then we have the absolute values divided by negative 1, so there's going to be a negative 1 there outside the absolute value. And then negative 1 divided by negative 1 is a positive 1. So now this equation here is the one that we're going to look to graph. So we can graph that as the absolute value equation and then shade it for the inequality part. All right, let's find our vertex here is going to be at 5, 1. So our vertex is at 5, 1. Put a point right there. And then our slope, if you will, of each branch of the graph is a -1. -1, so it's going to be sloped down 1 over 1. So I'm going to go down 1 over 1 on both sides and draw in my branches of my absolute value graph. Now we want to test a point. So we're going to test the point 0, 0, right, like we've been doing. So we're going to test the point 0, 0. We should test it in the original inequality. In case we made a mistake getting to here, we want to go back and test in this original inequality. So I'm going to do that. I'm going to use this to test my point 0, 0. So I'm going to put in 1 minus 0 less than absolute value of 0 minus 5. So that's 1 is less than 0 minus 5 is -5. The absolute value is 5. So 1 is less than 5. That's accurate. So this point 0, 0 is part of my solution. So that means I want to shade this part of the graph and then everything around the absolute value there. So it's going to look like this. Right? And she's shading all of this part of the graph. Okay? Nothing inside the V, just everything around outside of it. And we can go back and look, oh, I should have had a dashed line. So we want to make a dashed line then on our graph. A little trouble there with the dashed line part. So you'll want to graph a dashed line here when you are drawing your graph. And I can't seem to get it to draw a dashed line right now. So if we went back and changed this line here, it should be a dash. Okay? So when you get to that, make sure you're graphing that dashed line accurately. There we go. So I can make it a dashed line now if I want to, right? On both sides. Right? So a dashed line on both sides, and that way you've got your graph drawn correctly. Because the line of that absolute value itself is not part of the solution. So we don't want to have a solid line indicating that's part of the solution. It's just everything surrounding it. Right? So again, when you get these, graph your absolute value, use the vertex, graph the two branches of the V, and then pick a point. Generally 0, 0 is good to use, unless your graph goes through 0, 0, and that will help you figure out where to do the shading.